Hello and welcome to second lecture in sixth chapter of our comprehensive course on AI, ML and data science. Now here we wanted to learn about pandas, and in first lecture we have learned about what is pandas series. Now in this lecture we want to talk about what is pandas data frame. A data frame is nothing but exact creation of that kind of tabular data structure which we see in a CSV file or Excel spreadsheet. Okay, that is this kind of data structure, and we are very much familiar with this because most of the people's data analysis starts in this manner. Okay, so let us create that kind of data structure, but in using pandas. So it can be created in this manner. Uh, First, let me define what is a pandas data frame. So it is a two-dimensional, size mutable, potentially heterogeneous, tabular data structure with labeled axes, which are called rows and columns, and it is essentially a dictionary-like container for series objects. Now again, say what are the keywords? One is it is a two-dimensional. So clearly it will have some breadth on which columns will be distributed like this: sepal length, sepal width, petal width, species, etc. So that is the columns, and it will have certain height or length, whatever you call it. Along with some rows will be distributed like 1, 2, 3, 4, 5. Okay, so that is one thing, two-dimensional, size mutable. So currently this has 1, 2, 3, 4, 5 rows and 5 columns, but I can easily convert it by adding more elements or by removing, deleting entire rows or by deleting entire columns, anything, so that it may get converted into another pandas data frame which has currently 5 rows by 5, but it can have say 4 rows and 5 columns, or 5 rows and 4 columns, or 5 rows and 3 columns, or 3 rows and 5 columns, anything. Okay, just by deleting entire columns. So it is size mutable, potentially heterogeneous. Now this is very important. That makes it very suitable for storing any different types of data. For example, take this data only. Now here, this is all these are numbers, maybe floating point numbers, but these are strings. But all this entire thing, which is represent a CSV file or an Excel sheet, you can say, that you can store in a pandas data frame. So it does not mind heterogeneous elements. Tabular. So that is the first introduction to everybody's every student or learner with data science, that either he starts from SQL or Excel, and both are nothing but tabular data types, or that means this kind of data. Okay, so this kind of data. Now this data in more scientific language is called relational data, or it is also called structured data. Okay, so that is why the name of SQL is actually structured query language. We can find or we can perform various manipulations on this data using that SQL, but you can do the same manipulation with equal ease and efficiency using pandas also. Okay, so that is one thing. Then it is potentially heterogeneous tabular data with labeled axis. Labeled axis means this. So that is columns are like this and rows are labeled 1, 2, 3, 4 and so on. These rows are called indices. 1, 2, 3, 4 is called row index, and these are called column headers. Okay, so labeled axis. Now this sentence requires some explanation. It is dictionary-like container for series objects. Now what is the meaning of that? So let us try to create a data frame only, then things will become immediately clear. Okay, so if you see this, then this is actually one element of a dictionary, in which dictionary is nothing but key value pair, and we have already learned in earlier chapter a lot detail about dictionary, that it is always stored inside curly braces, and each element of a dictionary is a key value pair, where key can be a number, key can be a string followed by a colon, and the value also can be a single number, or it can be a string, or it can be a list or any other what you call iterable data type. Okay, so it can be. Now this is first element of my dictionary, this is second element of my dictionary, this whole, and this is third element of my dictionary. Okay, this is called first key, that is key K0 you can say, and this is called first value V0. This is called key 1, first key, that is actually second one, but index starts from 0, and this is first value. Okay, this is second key and this is second value. So 0, 1, 2, 3 keys are in the red color, and 0, 1, 2, 3 values, not 3 actually, 0, 1, 2 values are in green color. I can do one thing, that before I create the data frame, I can just print my dictionary just for my revision sort of. It will be printed in this kind of curly format, and those who are familiar, they know that JSON is also a format in which it will be it is printed like a JSON data structure. Okay, so you can see that this kind of format is there here. Well, then it's a list is the value, this is the key, this is the value, this is the next key, and this is the next value. Fine. But now I want to create a data frame from this. Then first you have to import that pandas as PD. Since I already have it, fine. But ideally, if you are starting new, then first you have to import pandas as PD. And once you import pandas, then you have to do just pd.data frame. To create series, what was the command? pd.series with uppercase S. Similarly, here it is pd.data frame again with uppercase D, and in parentheses you have to supply from which data you want to create your data frame. Here also in parentheses you supply from which data you want to create your pandas series. So it is fine. Now let us create that data frame and let us print that data frame. So now you see this kind of output, and that means a data frame is nothing but a table. If I find this exact table, what was the name of the table? It was, okay, we are creating custom table, but it is a table in which these are called column headers. So the keys become column header. If my data is specified in the form of dictionary, then its keys become column header, and its values, they become the value inside each row, successive rows, like these and this. Okay, so I think it is clear. And how values are given, that also you should understand. This is year column, so this will be given vertically. So 2020, below which 2021, below which 2022. Similarly, this is total population column, so these three will be given vertically, 320, 330, 340, and so on. Okay, and I have printed that data. So this is creating a standard way of creating a pandas data frame. Okay, and if I see that sentence now, then it is becoming clear. Last sentence, that pandas data frame is essentially a dictionary-like container for series object. Okay, so that means that this dictionary is now this much year and then one vertical column, that much, that is one series. So year 2020, 2021 and 2022, one column, that is one series. It is panda series. Similarly, this is another series, and similarly this is third series. So what is this whole thing? Then this whole thing is a container which contains three series. One is year series, total population series, and urban population series. And how those series are specified? They are specified by a dictionary with key value pair. So it is very easy to create pandas data frame. Now the question is, suppose I have created a data frame, say this only. Now I want to access various elements. Yes, before that standard thing also we should check always, that print df.dtype. Now we know now that what this d type will give. It will not give the data type of this new data structure which you have created, but it will give data type of every member inside that data type. And I think I will have to, let me say, it will throw error perhaps. Yes, so d types. Okay, so then you can see that it is a homogeneous structure here, because all columns are specified as integers. So first year column also has int 64, total population also has int 64 data, and urban population also has int 64 data. But how then I find the data type of what I created just now as a new data structure, that is the df. So then I told you that for that there is a standard method type, and inside you just put whatever data structure whose type you want to know, and that is now pandas.core.frame.data frame. So I hope that you are knowing difference between d types and type of df. Okay, df.dtype will give types of what are inside the data frame, and type of df, type in parenthesis df, will give the data type of df itself. Okay, so you must remember that. I have cleared those extra lines, and let me just re-execute because I don't want much clutter. Okay, now if I want to access individual columns or rows from one such data frame, say someone says access only year column, another person says access only total population column, another says that access only urban population column, then what to do? Then this each I should take in new cell. That would be much better. Okay, now even this line separator is not required because I have separated the cell itself. So fine. Now if you see this is my data set and access only year column, then it is very easy. You just write the data frame name, and inside square bracket, please remember, that means you are subsetting your data set frame and name of the column in quotes. So then it will give me year column. Only the 0th column is obtained, but all three rows are obtained. Now similarly, obviously I can get other two columns also. For example, this same command print, but instead of year column, if I am asked now get total underscore population column, then total population column is again name of the data frame, so it is df, and inside name of the column in quotes. So total underscore population. You have to write the exactly the same name. Okay, so that is one thing. And if I print that, then I will get the second column, or that is the first column, because this is 0th column first. Similarly, urban population can be found. Now I'm not showing that, but I'm leaving one cell. You can try. Now that was column by column accessing individual columns. Now the question is how to access individual rows. For example, this 0th row. 0th row means the row which has index 0. Okay. Similarly, first row means the row which has index 1. So I have to find the location of that row. That is, then I will use a command called iloc. df.iloc. iloc clearly says that it is finding location, but iloc, that means it is finding index location using the index. So in bracket, what you have to specify is not some value, but you have to specify index. So index is either 0 or 1 or 2, because this is a very simple data frame. Only 3 rows are there. So iloc, and as argument, not argument actually, but inside square bracket, you just write as a subscript or subsetting that write 0. So now you will get only 0th row. Again, interesting thing is my 0th row is like this, horizontal, 2020, 320 and 220. But when I use iloc and the output is obtained vertical, it mentions the 2020, 320 and 220, and it also mentions for our convenience the name of the column. So 2020 is in year column, 320 in total population column, and 220 in urban population column. So it maintains that. Okay. So this is the way to find the data from a particular row, provided I know the index from which I want to fetch the data. So if someone asks find the data of first row, then I will use df.iloc 0. Data of second row, then df.iloc 1. Data of third row, then df.iloc 2. So that is the one another thing. Then one more thing is that this row for which, now here I am finding a particular row, this row, by specifying its index. That's why the function's name is iloc, index the location. Okay. But if I want to find a row by some value, for example, find a row where year is equal to 2021, or find a row where total population is equal to 340. So at that time, what you will do, you cannot use iloc, because you don't know the index. The total population 340 may be here, or maybe here, or maybe here, because see data here we are seeing the data frame output, so I can immediately see it. But finding the same thing programmatically means as if you are not able to see the output of a particular data frame, but you are just asked that one of the entry in the total population is 340, then find me in which row that 340 total population is present. So then for that you have to use conditional statement with df.loc. I am not using iloc because index is not known. Index itself is what this much will find. So what this will do, it will find the index that df.total population, df in bracket, the column name is total population, equals 340. So that means this comparison operator ensures that entire df is not fetched, only that subset of df is fetched for which the condition, that is total population, is equals 340, that is satisfied. So only this subset is fetched, and then print that subset, store it in some row and print it as subset. Then you can see that I am getting that last row, this one. Okay. So if you want to find the data from a pandas data frame by using the index of the row, then use df.iloc. And if you want to find the data from a pandas data frame using some value or some condition, then use df.loc. Okay. So that is one important thing. However, there is one another way of doing this short form, in a short form, that it is written this way: df and then df underscore total underscore population, okay, equals 340. Now what is this? Here actually we are taking two subsets of this. What is this df total population? We earlier just now today only learned that in this lecture only that will fetch entire column. So that means that will fetch what? That will fetch, where is my df? Yes, this. So it will fetch this entire column, total population 320, total population this and this. It will not fetch the year column, or it will not fetch urban population column, because I am specifying I need only one column. So df dot this total population will fetch only this column, that is first column. This is year is the 0th column. Okay, so first column, and then it will now from that. So that is a subset of my original data set. data frame, and now again I am taking subset. And this time, how I am taking subset? By using a conditional operator. That I don't even want my entire column. I just want that many records, that row for which the value in the column total population is equal to 340. So from the first this total population column also it will fetch only this record. That is clear because that is the only record where value is reaching this one. And then I can print that row. And in that case also you will see that we get the same output as the previous one. Okay. So by df.loc, so if you want to get a particular row without knowing its index, but you know something about that row, that row contains this element in this column. So you should be knowing the name of that column and you should be knowing the value also. That what then you can easily find the row in the total row for which total population is 340. Okay, and you can easily calculate by this method also by double subsetting. First subset the entire data frame so that you can get column total population column, then subset that part, so that means that is this much. Okay, that will give you this column, and then subset that part further by writing that I don't want all total population, I just want that total population which is equal to one particular value. So that is this 340. So only the element which are at index 2 they are okay. Okay. So these are two things, and this is just explanation. Just like we can explain one individual column by specifying year column, the name of the data frame, and that particular column's name in square bracket. Similarly, we can easily find multiple columns also. For example, someone says that from this whole data frame, take a subset which has year and total population together, like these two, year and total population together. Okay. So if you use those two, then in that case, you can get that by this method. Multiple columns, year and total population, they are supplied as a list, and therefore this whole thing is a list of lists. So the most important difference which you can see is that when you want to access individual column, then you just write the name of that column. But what to do if you want to access say three columns from a data frame? Then simple, pass name of all three as a comma separated list. So that is what here I am doing. Here I want two columns, then I have passed the name of those two columns as comma separated list. And instead of writing the name of column, if I am accessing simple column, write that list inside df and that square bracket. Okay, so I will easily get the required data frame which I want only first two columns. So multiple columns can also be accessed by using two square brackets. If it is not clear, then you can just write this way, then it will become more clear that actually you are just taking subset. But for taking subset, if there is only one row, or sorry, one column which you want, then there is no need of list. But if there are multiple columns which you want, then they should be supplied as a comma separated list. In fact, even for one column, if you supply in a list, then it would not create any error. But we don't try to like to write more. That is why. Otherwise, you can say that I am accessing for if you don't want to remember too many things, then just simple thing you remember that for accessing a column or columns from a pandas data frame, use df inside square bracket the name of that column or the names of that column, those columns in a comma separated list. So here I want only one, so name of the column, and here I want many, so names of the column in a comma separated list. A very simple thing. And in next lecture we will do this, creating a data frame from list of dictionary and some further things. This next lecture is going to be very important, so please don't miss that, or don't skip that. If you are learning and skipping a few lectures here and there, don't skip the next lecture. Okay, thank you.